Hello, good morning. This time I'm going to make this video in English because I want to make José Carlos Pereira a little bit more international, and I hope to have your support, okay? So let's consider the function f, which domain of f is the open interval from minus infinite to 2 open, and the function f is defined by f of x equals 1 minus logarithm base 3 6 minus 3 times x. So we want to find the solution of this inequality over here, you see. So first of all, I'm going to substitute f of x by this value over here. So let's continue. It will be 1 minus logarithm at base 3 6 minus 3 times x minus, and now you must be careful because you are going to substitute this value, you see, here at the value here at the function f. You are going to substitute 1 minus 2 times x, this value, at x at the function f, you see. So you must be careful with the signs. So I'm going to open over here an interval, and so it will come 1 minus logarithm base 3 6 minus 3. I'm going to open again another interval, 1 minus 2 times x, and I'm going to close the interval, and this is greater or equals to 1 plus logarithm at base 3 of x. Is this okay for you? So I'm going to continue. There was an interruption. You speak English a little bit?
No.
No? No, I think you can speak a little bit, but I want some support, you know, to continue to do this exercise. So let's continue. So I will have again 1 minus logarithm at base 3 6 minus 3 times x. Now I'm going to make the calculations over here, 1 minus logarithm at base 3, and now carefully I'm going to make these calculations. 6 minus 3 plus 6 times x, and I'm going to close the interval, greater or equals to 1 plus logarithm at base 3 of x. So now, as you can see, I can cancel at once this number 1 with this number 1. You agree with me? Okay. Thank you so much. So I'm going to continue, of course. Minus logarithm of 3 at base 3, I'm sorry, 6 minus 3 times x, and now I'm going to, you see, minus plus it is minus 1 plus logarithm base 3. I will have 6 minus 3, it is 3 plus 6 times x, greater or equals to logarithm of x at base 3. Now, as you can see, I have another expression. At the beginning, the domain, it was this one, and this is the domain of the function, okay? But now I must find again the domain for this expression. But you never can forget about this domain. I don't know if you are understanding what I'm saying. Are you? So at this expression, the domain, it must be 6 minus 3 times x greater than 0. It is a logarithm. And 3 plus 6 times x greater than 0, because of this. And also because of this it is x greater than 0. Okay? Is that okay for you? So now I'm going to solve each one of these inequalities. For the first one, I'm going to make here at this corner some calculations, and it is minus 3 times x greater than minus 6. So x must be lesser than minus 6 over minus 3. So it is the same as to have x minus lesser than 2. Is that okay for you? So here I will have x lesser than 2, and here I think you can do these calculations by head, can you? This number 3 jumps for the other side and is going to divide by 6. So I will have x greater than minus 3 over 6. It is the same as to have minus 1 over 2 and x greater than 0. Is that okay for you? So now I must find the solution of this. So I'm going to draw here a line. I'm going to put here the numbers. The first one it is minus 1 over 2. The second one it is 0, and the third it is 2. Let us see. X greater than 0. It is over here, okay? I'm going to draw this at white color. Then x greater than minus 1 over 2. Let us say with another color this one over here, okay? I think it is very simple to understand. And at the end I will have again x greater than 0. It is here, you see? So it is in this domain, you see, that I'm going to work, but you must put all time your eyes over the domain of the function at the beginning. Are you understanding? So I must make the intersection of this interval with this one. What is the interval? What is? So I'm going to make the interval minus infinity to 2. I think it is open, I don't know. Yes, open. And I'm going to intercept with the interval 0, close at 0, close at 0, no, it is open at 0, I'm sorry. Open at 0, open at 0, and open also at 2. It is quite simple to understand that is the interval from 0 to 2. Did you understand or not? For sure? So now I must work in this interval. So if I must work in this interval, I'm going to make the solution of this inequality. When I have logarithms, I like much more to have sums than to have divisions, because if I have sums with the logarithms, I will have products. If I have if I am subtracting, I have quotients, you see. So to have products, I must do the follow. I'm going to keep this logarithm at the first member, and I'm going to put this logarithm over here and this number minus 1 to the second member, okay? So I will have logarithm at base 3 plus 6 times x greater or equals to logarithm by 3x plus logarithm by base 3, 6 minus 3 times x plus 1. Okay? So let's continue. I will have again logarithm at base 3 plus 6 times x greater, and now you must remember a great property of the logarithms. If I have logarithm at base a, let us say u, plus logarithm at base a, let us say b, this is equals to logarithm at base a u times b. Do you remember this property? So if I have here 1, I can transform 1 at a logarithm at base 3. It is quite simple, because I can put here logarithm of 3 at base 3. It is the same as to have 1. You agree with me? Because the logarithm of a at base a is all time 1. So here I have a product. Logarithm at base 3 x times 6 minus 3 times x times 3. Is that okay for you?
Yeah.
Thank you. So, as the logarithm, as the base of the logarithm is greater than 1, this means that the logarithm is all time increasing, like this, you see? So when I have this inequality, I can cut. It is like I cut the logarithms, and I will have 3 plus 6 times x greater or equals, and now I'm going to make here the calculations. You must look that I have x times 3, it is 3 times x, so I will have 18 x minus 9, 3 times 3 it is 9, x times x it is x squared. I think I did not make no one mistake. What do you think? So let's continue. If I did not make no one mistake, let's continue. I will have 9 x squared. This is going to the first member. I will have, it is quite simple to understand, it is equals to minus 12x plus 3 greater or equals to 0. Okay? Now I want to put this expression a little bit more simple, and I can divide by 3 all the expression, the left side and also the right side. And I will have 3x squared minus 4 times x plus 1 greater or equals to 0, okay? You must understand now that this here, it is a quadratic function, and the value of a, it is positive. This means that the quadratic function at the graph of this function, it will be something like this, you see? Are you understanding what I'm saying? So first of all, I'm going to have the zeros of this. The zeros, it is quite easy to understand. Minus b, it is 4, more or plus minus square root of 16 minus 12, okay? Over 6. And so I have two solutions. First of all, it is 4 plus square root of 4, it is 2 over 6. 4 minus 2 over 6. Here it will come 1, here it will come 2 over 6. It is 1 over 3, okay? This means that I have here 1 over 3, and here I will have 1. And what I want that this over here, it must be positive or equals to 0. equals to 0, it is at 1 and at 1 over 3. Greater than 0, greater, you see, it is above, you see, the x-axis. Are you understanding? So the solution of this inequality, it will be x belongs to the interval minus infinite to 1 over 3, and I'm going to make a union of the other one interval, that is this one over here, one open interval, open, not open, it is not open because it can be equals 0, you see, so I must close here the intervals, close, okay, because it can be equals 0. Don't forget please about the domain. In the domain it was like this, the open interval from 0 to 2, okay? So I must again do the intersection, you see, of this interval with this one. What is the intersection? I think it is very easy to understand. If I have here 1 over 3, if I have here 1, I have here the right side, I have here the left side, open intervals. Where it is this interval, of course it is more or less here and here. So at this color yellow, I think you can see very well that the solution, it will come where the yellow color and the white color appears, and so I have the solution. It is the interval closed at 1 and open at 2, and so this was the solution. Did you understand? Oh yes, you are right, I made here a mistake, because 0, it is not well located. I'm sorry, I'm going to clean the figure, and so 0 must be over here, okay? So if I have 0, if I have 2, I'm going to paint again, and so I have 2 intervals, okay? The first one, it is from 0 to 1 over 3, open, union with another interval, which is 1, closed at 1, okay, and 2, open at 2, and this is the solution of the problem. Então, I think this is a solution.
No.
No?
Não, acho que se enganou.
Oh, where?
Terço. Devia ser fechado.
Let me see. Oh, yeah. You are right. It is closed. Yes, you are right. Thank you.